Welcome to another episode, thrilling episode of The Math Path. Today, well, you'll remember 2 days ago we were reviewing, wow, look at how fast and faster he's going up that hill, down the hill, I mean. Now he's going slower and slower. We learned about multiplication. Annabelle did a great job, didn't you, Annabelle? I was very impressed. She did a great job with multiplication and division. We also learned what is a number. And so today I decided we're going to learn
math.
About calculus.
Calculus.
We missed the day yesterday,
yesterday.
but it's now September 28th. You should never miss a day on the math path, by the way.
If you want to try this in three,
And
then two.
Every day.
Two.
Every day. Otherwise,
Two.
I don't even know. So, I've made a little thing, and Annabelle has nicely put the little 3 dots on some of them, which are not, it's very decorative. Okay, so here, if you could put it up higher so we can see above what's going on. So.
You can't see very wide though.
Well, no, I mean from overhead, so you can look down upon the, can you see them? Okay, so we have some globs here. 1, 2, 3, 4. Look at this, 5, 6. All right, now, on a glob you can put any number. Okay, you've done this, but you can put whatever number you want to multiply it, right? So this is 2 times 3. Okay, you can times it by anything. But we're going to learn a new concept. There's another operator. It's called generate. Okay, we'll make a symbol for generate. And what it means is you take and multiply it by itself specifically. Okay, so whatever the glob is, you're going to times it. You're going to do it itself times, okay? So.
Like 4? That would be 4 down there?
That would be 4. And look, here's the 4, okay? So what if you did it to this 3?
Then it would be 6.
Yes.
No, it wouldn't.
No, it wouldn't, actually. What is this number?
That is 9.
That's right, and that is what you get if you
19.
do 3 times. Look, 1, 2, 3, 1, 2, 3.
Yeah,
If you do it to 4, we haven't learned this one yet, but it's a very pretty number called 16, okay? So, you may notice something about the shape of these numbers, but anyway, so there they are, right? These are all these generated numbers,
But look,
right?
here's
In the
one.
second generation.
Here is a number.
Okay, so well, here's something, all right? Let's look out the window again at Caleb riding his bike, okay? So, one thing you get for the math path is you're not going to be intimidated by all these things, because every concept in math is simple. Okay? Simple. Like simplex. Not complex, unadulterated. If it's not simple, then it's probably false. Alright? So here, come back over here, and we're going to learn about calculus. Okay? Because what calculus is asking, so let's say you're Caleb and you're going down the hill and you're going faster and faster. Alright? And let's say the rate that you're going faster and faster is defined by this generation thing, okay? So you're going faster and faster and faster. So you can see where you are after, after 1 second, you've gone 4 feet. After, 2 seconds, the first second, okay, we'll do the first second. The first second, you get 1 foot. Then the second, now you've gone, then you've gone 9, then you've gone 16, okay? So that's easy. But calculus asks crazy questions like, all right, how fast are you going? How fast are, not where, just where are you? How fast are you going at any given time here? How fast? All right, so how do we know this? Let's look at something interesting. And guess what? Your calculus teacher probably didn't tell you this because your calculus teacher probably didn't understand calculus. So, let's get rid of these 3's.
My calculus
What?
teacher always used to tell me that your elementary school art teacher lied. And now you're telling us my calculus teacher lied.
You did lie. You should always hold scissors towards yourself. That way, if you slip and fall, then you absorb the blow. It's much safer. So, if you take, what is this
I don't think so.
minus this?
What did you say?
What is this number if you take away this number? 3, that's right, Annabelle. You say it's easy. You say it's easy. Not only is calculus simple, but maybe it's easy. Okay, now, what is this number minus this number?
That is easy. That is 5.
Wow, you can do that just in your head? That's pretty good. Yeah, okay, so it is 5. You're right.
I took
What is-
away these ones and said, oh,
Okay,
it's 5.
that's right. Okay, so this one you might have to, this one you can play with a little bit if you need to. So what is this number minus this number? Okay,
15. That is, yeah.
you know how you can do it?
7.
Look, just go.
7. I said 7.
But yeah, you're right. Oh wow, it is. It's 7. So
How
how did you do it? Because you didn't even touch them.
I just went like, take these away, then I would go. And
And then
I
you
added
counted these?
and then I added these together, made 6.
In your
and then
head?
1 more, 7.
Yeah, 1, 2, 3, 4, 5, 6. So you
But I
added these two and these, and then
I
that one.
didn't even count these. I just made 3 and 3, and then I pretended I put them together, and then I knew that there was 1 more.
Very good. Okay. All right. Well, excellent. That is good to know. So,
I did in my head.
impressive. 了不起. So,
No kids will understand that.
they might.
You're right, kid.
In China, they'll understand it. So, Winifred, can you move away? Because this is calculus, not
I'm sucking.
laying on the floor. Here, okay. So, notice something, dear viewers. Wow. Okay, now, let's do something else. What is this number minus this number?
Oh, that's easy. That's 2.
It's 2. What is this number minus this number?
Oh. That's easy 2.
2. Now, let me assure you, there are other numbers. The numbers continue indefinitely, not infinitely, but indefinitely. So there's this 6. So let's see. If we're going to, we got 3, we got 5, we got 7. In the interval between these let's just call them squares. Between the squares, the intervals are going up like that. The interval between these 2 squares is 3. These 2 squares is 5. Between these 2 squares is 7. I wonder what the next number would be. 3, 5, 7. What's next?
A.
No. We're counting by odds. 3, 5, 7.
6.
No. You need to work on counting by odds. Winifred, do you know?
9.
1, 3, 5, 7. Yeah, 9. So, let's see. If this one was 16, what do you think the next square is going to be?
Wow.
9 plus 16. Lo and behold, whoa, it'd be 25. And then what's the next one after 9? 11. Do we have a square at 36? Oh, that's deep. What's going on here? This is the whole thing. So, we can say, guess what? Look at this, look at this, look at this. Okay, we're messing up calculus. You can't mess up calculus. So, you have all these numbers, and guess what? What the rate is at... Okay, so this is the rate. This is the speed. This is a derivative, right? They call it. But this is also known as how fast is the bike going. It's not really that complicated. Oh, dear.
Because you weren't. Yeah.
That's the punishment. I'm sorry. Okay, so in between, halfway in between, when x, when the number is 1, when the number is 2, guess what the rate is? The speed of the bike is 3. So at 1.5 seconds, hey, I don't even know. At 1.5 seconds, we are going 3. And at at 2, in between 2 and 3, 2.5 seconds, we are going 5. In between 3 and 4 seconds, so that would be 3.5 seconds, we were going 7, if you recall. So this is so simple. Look at this. Why did you not know this? You might have known this if you're very smart. I don't know. It's just simple number theory. It's the nature of the numbers. What's on? Why is it not focusing? Anyways, so that's how fast Kayla's bike is going. It's just, that's what calculus asks, right? So it's always half. It's always half, isn't it? So like if and guess what? It works for the cubes too. It works for the cubes. You can go 1 and then 8 and then 27 and then then you subtract the 64 and you say okay, the difference is 7 and then 19 and then all these things and they go up. But you have to do it one more time and then you get to a flat line. The flat line we didn't actually show you, but it's 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. On the cube, you'll get to, if I remember correctly, 6, 6, 6, 6, 6, 6, 6, 6, 6. So there we go. Sorry for all the crying and injuries during the video. Did you have a good time with math? Ta-da! Thank you for joining us.